I'm here with the Arcee AI team. I'm personally have become a bit of a fan of Arcee because I think what they're doing and trying to build a company around building open models is a valiant and very reasonable way to do this because nobody really has a good business plan for open models, and you just got to try to figure it out, and you got to build better models over time. And like open source software, building in public, I think is the best way to do this. So this kind of gives you the wheels to um, get hit the ground running on whatever you're doing. And this week they're launching their biggest model to date, which I'm very excited to see more kind of large scale MOE open models. I think we've seen, I don't know, at least 10 of these from different providers from China last year. And it's obviously a thing that's going to be international, and a lot of people building models. And the US kind of, for whatever reason, has fewer people building open models here. And I think that wherever people are building models, they can stand on the quality of their work. But whatever, I'll stop rambling. I've got Lucas, Mark, Varun on the phone here. I've known some of them, and I consider us friends. So we're gonna kind of talk through this model, talk through building open models in the U.S. So thanks for hopping on the pod.
Thanks for having us.
Yeah. Thanks for having us. Excited.
Nice to be here.
What should people know about this Trinity Large? What's the actual name of this model? Like, how stoked are you? Like, are you like, we finally made it?
We're recording this a little bit before release, so it's still like, getting everything buttoned up and inference going at that size is always a challenge. But this has been like a 6-month sprint since we released our first dense model, which was 4.5B in July of last year, 2025. So it's always been in service of releasing large. It's a 400B, 13 billion active sparse MOE. And we're super excited. This has just been the entire thing the company's focused on the last 6 months. So really nice to have kind of the fruits of that start to be used by the people that you're building it for.
Yeah, I would say like the realistic question, do you think this is landing in the ballpark of the models in the last 6 months? Like that has to be what you shot for, is there's a high bar of open models out there. And like on what you're targeting, do you feel like these hit these, and somebody that's familiar, what Minimax is like 230 total, something less, I don't know what it is, like 10 to 20B active probably. You have DeepSeek's in the 600 range, and then you have Kimi at the 1 trillion range. So this is still like actually on the smaller side of some of the big MOEs that people know, which is like freaking crazy. Especially you said 13B active is like very high on the sparsity side. So I don't actually know how you think about comparing it among those. I was realizing that Minimax is smaller doing some data analysis. So I think that it's like actually the comparison might be a little bit too forced, where you just have to make something that is good and figure out if people use it.
Yeah, I mean, if from raw compute, we're roughly in the middle of Minimax and then GLM 4.5 as far as like size, right? GLM's like 380, I believe, and 34 active. So we go a little bit higher on the total, but we cut the active in half. It was definitely tricky when we decided we wanted to do this. Again, it was July when it was July when we released the dense model, and then we immediately knew we wanted to kind of go for a really big one. And the tricky thing with that is knowing that it's going to take 6 months. You can't really be you can't be building the model to be competitive when you started designing it because obviously a lot happens in this industry in 6 months. So when we threw out pre-training, and a lot of our targets were the GLM 4.5 base model, because 4.6 and 4.7 have been post-training on top of that, and like end performance wise, it's well within where we want it to be. It's going to be, technically, we're calling it Trinity Large Preview because we just have a whole month of extra RL that we want to do.
I've been there.
yeah, but we're in the mid 80s on AIME 2025, GPQA Diamonds 75. At least with the checkpoint we're working with right now. We're still doing more RL on it, but MMLU Pro 82. So we're happy. We're really, like, for it being our first big run, like just getting it trained was an extreme accomplishment, but then for it to actually be like a genuinely useful model is a cherry on top.
Yeah, let's go big picture, like let's recap. We have this full trinity of models. I think that there's a fun note. Did I put it in this doc? Yeah, on Nano Preview, which was the smallest. You're
Mhm.
like charming and unstable. The model card's really funny. ChatGPT, doing deep research on this, I was like, ChatGPT Pro just tagged next to it charming and unstable, and I was like, is this a hallucination? And then in the model card, you have like, this is a chat tuned model with a delightful personality and charm we think users will love.
Yeah.
It's pushing the boundaries, 800 million active parameter, and as such may be unstable in certain use cases. This is at the smallest scale, which is
Yeah.
like, I appreciate saying it as it is, and that'll come up multiple times in the conversation. And then you have mini, which is like, I think it was like 1B active, 6B total type thing. I don't have it, the numbers right in front of me. I have it somewhere else.
Yeah,
It,
Nano was the 6B one
oh yeah,
active,
yeah,
and the Mini was 26 3B active.
yeah. So like, are these
Yeah.
based on more of like you need to build out your training chops, or are you trying to fill needs that you've heard from community? And like, I think for context, previously, your first open model was a base and post-trained model, which was RC 4.5B, which was the dense
Mhm.
model, which people liked. And prior to that, you had like a long list of like post-training fine tunes that you had
Yeah.
released. So before that, it was like a post-training shop. And I think that kind of history is important to fill in. I think a lot of people are going to meet you for the first time listening to this.
Yeah, we chose those sizes for Mini and Nano, specifically Mini, the 26B 3B active, because we wanted to de-risk large. This has all been in service of getting to a model of the 400B class. So um, we learned from doing the original 4.5B that you might have everything on paper that you need to train a model, but inevitably there's tremendous difficulties that come up, and we definitely knew we wanted to make sure that we solved some of especially when it came to just doing an MOE model performant, like an efficient fast train of an MOE. So we thought that that was a good ground where we could, it wasn't crazy expensive, but gave us a lot of data going into large. And then Nano just came about because we had some extra compute time, and we really want to do more research on like smaller models that are very deep, and we hadn't really seen that in an MOE before. So that one was very much, we started training it, and then early benchmarks were good. So we said, well, we'll just do the whole data set. And but most of the love for those releases went into Mini. So I definitely think that long term, from an ROI perspective, the smaller models are going to be where we shine, just because there's a tremendous amount of cost savings a company can get from optimizing on a smaller model. Um, but we're definitely going to be trying to push the large frontier too.
Yeah, I'd like to kind of double clip on training before going back to this small model is useful for companies, because we're gonna end up talking for like 20 minutes plus about open ecosystem. So I kind of am curious, like philosophically, how your company feels about like sharing scientific details. So if I ask you like, what are the things you're technically most excited about in the model, or like what are the pain points? Like, are you willing to talk about these things?
Yeah.
Do you feel like it's kind of orthogonal to the company? Like, I feel like a lot of it is just like things that happen. I think your framing of all of this is in service of getting the big model going, and
Yeah.
particularly of like you have to be thinking about your model as landing in 6 months is probably like for people not training models, it's hard to think about, because even
Mhm.
I'm thinking about trying to refresh our post training stack for Moat 3, and I'm like the thinking model, the um we are pretty SFT heavy right now, and it makes it not very dynamic in terms of the thinking time.
Mhm.
And it's just like I can't see people deploying this model, or probably will have a hard time fine tuning it. And it's like to think about where tool use models are going in 6 months like seems pretty hard. It's a very hard task to do, so it takes a lot of gumption to actually set out and do it. So I would just appreciate the framing, kind of self-reflecting on what I go through. So if you have anything that you think was like particularly hard to actually land the 6 month outlook, because you use Muon as an optimizer, or is it Muon,
Yes.
and some of these things. I think the data, it's well known that Datology is cranking a lot of this, and you probably provide, I think of it as like you're kind of driving and working with these partners, and I'm sure you provide a lot of feedback on what's working and
Yeah.
what's not. So
Yeah, I mean,
anything
from
you're willing to
on
share, I think it's useful.
I think I mean, on the data side, like datology, I at least for these models, that partnership has very much been almost an extension of our own research team. Like we've worked very closely with them, and um, obviously our model's doing well. Is good for them. So, um, but there was definitely, and you know this better than most, like small scale ablations when you throw them at scale, sometimes the it doesn't always turn out how you want. So there was quite a lot of iterating there to at least get the data set we used for large. I would say that as far as looking out 6 months and then figuring out how we wanted to, obviously the big one was compute. We don't, we never raised as like a foundation model company, so we haven't signed massive commits for thousands of GPUs before. Um, we didn't have a massive cluster that was always active for a lot of our post training stuff that came before. We had 64 H100s that was pretty sufficient for that kind of work, but obviously this necessitated quite a bit more. So
That's
the
still
first thing
less than
was,
people would guess. Like you're releasing models
yeah,
that weren't like your models weren't catching national news, but people in the community knew about them. And
yeah,
like I think of like Moondream when I think about that. Like Vic has
yes,
such little compute and he puts it to so use. So you like see how successful he is, and he
yeah,
tells you that he has I don't know 30 like it might be like 64 GPUs. Like
yeah,
there's that's a whole separate conversation on building
yeah.
actual good ML output on little compute. I should chat with Vic about this, but
No,
aside,
it is. I think it was, yeah, it was very much a gift going into the pre-training side because we were kind of already thinking, all right, how do we do the most with the least amount of compute? But um, we it took us quite a while to get the cluster that we have been training large on, which is 2048 B300s. Um, and once we figured out when we were going to get access to that cluster, everything else kind of became clear as far as like timelines for mini and nano and when we wanted to do that. Obviously, 512 H100s was easier to come across for mini and nano. So once we figured that out, um, it really became this game of, okay, how can we find like the best research on the topic of pre-training, and what are the papers and publications that are coming out that have enough potential and enough precedence, either because another lab used them, it comes from a reputable team, the ablations and the evaluation setup like in the paper was sufficient enough to give us confidence, and then we basically spent, I don't know, it's probably about 2 months just figuring out what we wanted our architecture to be for the MOE, then figuring out, okay, now that that's what we want to do, how do we implement all of that in the actual training pipeline? How can we, at that time there had been many people who'd done Muon, but um, for post training, and then some Chinese labs had used it, but there wasn't like a widely available distributed Muon
what do you think
to
that
do at
like
that
looks
scale.
like in decision making? Because that seems like a risky decision, if you ask me. I think for one, the
Muon,
timing, the like timing sharing that you're saying is good. Like you said this for 2 months, and then like, but like even Muon is like that's a bet that would even take like somewhere like AI 2 that would take some serious evidence to go with it. We would want to ablate it. So like on a
yeah.
single track, it's like you probably had a process for becoming fairly confident in it then.
It Yes, but it was also like Kimmy had just come out, and we knew that that one used Muon, and so we knew that it, at least if implemented correctly, could deliver a good model. There weren't outstanding ablations done around, like, there wasn't a Kimmy scale model done with Atom and then compared to Muon and see the difference. But that at least gave us enough confidence that
What does Muon
if
give you? Does it give you like memory saving in
no, it's actually a little bit more memory. It's mostly
It's
like the loss converges a bit quicker.
it's less memory actually. only one momentum buffer instead of atoms to beta buffers, and then it's also better convergence.
Okay. So it's like mostly designed around convergence, and then I know the math is different, which is where this momentum term
Well, it kind
changes.
of came out. I mean, it had its big, explosion of popularity in the kind of nano GPT speedrunning community. So it was kind of all built around converging to a certain, validation loss faster, and that was. As for why we chose it as opposed to Atom, we'd used Atom for 4.5b, but we also knew that if we wanted to move this fast, that we were going to have to make some pretty big bets. Educated, but still, we would have to make some risky decisions beyond just training in general. So there were a
Like,
few that Muon we went with. I think was one of our bigger bets. We ended up not doing like multi-token prediction or FP8 because we were throwing so many new things into the run at once, um,
did
that
these apply
if something
for
were to go wrong,
Mini and Nano? Are these also Muon or are those
yeah,
Atom as well? Okay, so then
yeah.
you get some de-risk from that. Do you know off the top of your head how many days it take to train each of those? Like, this is a good
Uh,
ballpark for people before
yeah.
going into the
So
bigger run.
so mini. Uh, so nano on it was 512 H200s. Took a little over 30 days. And then mini was about 45 days.
Okay. I think another
Yeah.
thing off the top of my head is I know that like a Olmo 1B dense would take us like 11 days on 128 H100s for a dense model to
Yeah.
like
Yeah. I mean,
16. So like the
yeah.
numbers just go up from there. Because then it's like the question is like, I'm guessing if those are 45 days and then you up the number of GPUs, it's going to be like a similar amount of time. We're 40 days for the big model, but much more stressful.
Yeah. The big model was, but again, that was, we knew that we wanted, we felt confident that we could deliver a competitive and exciting model in January 2026. Like we knew that we could, who knows kind of where the research and what class and skill and performance of models going to come out in the next 3 months. So we also knew that we really wanted to land sometime in January. And that's also why we went with B300s, even though definitely the largest public train of that size on B300s, and um, a lot of the software did not have like out of the box B300 support. It was the only way we were going to be able to train a model of this size
Did you have to do
in.
this? Did you have to implement the like help solve version issues or other issues on B300s? Because I've heard this
we
that rollouts
we
have
had,
been rough.
we had to add a bit. There were a couple days where the data center had to take it offline to implement some bug fixes. It was it was definitely like a very cool experience being on the bleeding edge, but also like a little frightening because you just know like, oh, we're not getting the most out of these that we possibly could. So a little bit of both.
Was your final training run stable, or did you have to do interventions through it?
It was very stable actually. It took the beginning of it was not. The first 10 days were absolute. It it would start very well and looked, the dynamics and the logs and the graphs looked very similar to mini and nano, and then after around a trillion tokens, you'd get collapsing. Experts would start to go crazy. Part of this is just, again, we are very sparse compared to what you have. So, 400 billion total, um, 13 billion active, 256 experts. Like it was.
Did you do a expert routing loss or some sort of balancing loss?
Yeah, yeah,
Yeah.
We did. We used DeepSeek's. We modified DeepSeek's Oxfree loss balancing with our own with some tweaks, and then we also added a sequence loss like they did as well.
Was there Ox free one from DeepSeek V3 or was that a later model?
That was V3.
this V3.
Yeah, that's
Yeah.
I
They
was
did a
just
separate
clarifying.
paper on it as well. Yeah.
Yeah, yeah, that makes sense. I think a lot of people have derived from there. Have you
But
had issues on post training as well? So I have a theory that the new algorithms we're getting from the Chinese labs, like GSPO and CISPO, are primarily for problems that you solve when you have big MOEs and you have expert problems when trying to do the RL. And
Yeah.
that's the whole reason that like I think our very serious AI2 RL setup, like we're doing it on dense models and we're just like, it's fine. We don't have this big clipping problem and as much like we don't have as much of a need to get the batch size as big to activate all the experts. So you're saying you have so many experts and so much sparsity that potentially sounds like you're making RL harder.
Um, yes. I will say that from just like a purely post training side, we added as much as so our code base started from Torchlight. We've had to make a ton of modifications to it to get it where we needed to be, but that was an excellent base. And from one of the bigger learnings from Mini and Nano was treating at least the SFT side of it as a separate phase. Because with Mini and Nano, we finished the pre-training, we did context extension, then we took those and then ran those on like the 64 H100s we usually would do post-training on. That presented a lot of challenges with the MOEs. They really, and that's kind of been a thing in the open space, is post-training MOEs like really can be frustrating even for SFT. So for large, we added like fine-tuning directly to Torch Titan, and did it all on the same cluster. So from a performance standpoint, like SFT was very actually ended
What
up
is the
being
actual
totally
difference
fine.
between the implementations then? Is it just kind of like you end up with different batch sizes and parallelism and stuff? Like
I
why?
mean, we ended up needing to get it to do really like to get context parallelism really well, really good because we're obviously going at a higher sequence length, and then just adding the proper loss masking. It ended up being a relatively easy implementation, especially because we did all the pre-processing outside of Torchlight. And
Interesting.
then on the RL side, yes, I would say it's not. It didn't present itself as significantly harder than Mini and Nano. However, that many GPUs does, so we didn't end up using 2,000 of the B300s for that. That ended up being 1,000. So two, we just split the nodes in half.
Yeah, that makes
On the
sense.
dense model side of things, you mentioned that you didn't need to use all the tricks and stuff. I think it is. I think MOEs are just in general harder to RL, but I think it's also like because of like the KL mismatch between trainer and inference engine, right? Where you have like sometimes the inference engine can pick different experts compared to like the trainer when you like do a forward pass on the same tokens. So I think there is definitely some like inherent instability with RL and MOEs.
Yeah, that makes sense. Okay. Another question of like, how much do you want to say? How do you feel about the state of public post training recipes? Like, do you like? I feel like there's so little out there, and there's an opportunity to be seen as technical leaders by sharing just like more of what you're doing. Because I feel like we've seen for years how complicated things can be, but also I kind of at the same time like we see this from the likes of Llama has these really complicated recipes, but at the same time I feel like just executing on a simple recipe can get pretty close. But it's just like I feel currently unsatisfied with how much I know about what are the actual core trade-offs of doing post-training well. And I think you could do a lot with SFT, but there's definitely in this RL regime more trepidation of kind of narrowing your model to either downstream use or like being able to do this multi-week RL run where you get the most performance.
Yeah, I mean, I from since RL has become such a pivotal part of the process beyond what DPO and kind of your typical RLHF was in the past. Like we used to get quite uh sophisticated with how we would do SFT and even our RL. We obviously we make merge kits, so we utilized merging and we used to do a lot of distillation um, to eke out as much performance as we could. Now that RL is such a massive part of the entire post training stack, I have almost reverted us to just really solid but simple SFT. Um, like in large, I mean, we've our post training data set for Trinity Large is 230 billion tokens. Like it just like a really
That's
really really
10x what we
large.
did,
Yeah,
at least
it's
in
and even
S&P.
that, and even your tenant, like that was before this kind of going at this scale, and even kind of thinking and reasoning models. Like our largest SFT before that was 5 billion. We do like three epics, but it's like 5 billion, tokens. So,
Yeah, our
um,
non-reasoning model is like another 10x. So like our most latest instruct model is like 2 billion.
yeah, which is already a lot, So, I've definitely simplicity's key because it also makes debugging anything easier, and then devoting a lot of that sophistication to the RL part's like really important. I do think that, I mean, the next phase of reinforcement learning for models of this scale is just scale. Is okay. We went from 20 billion SFT to 230. Now we're going from 10 environments to 100. I think that really is where you're going to get the biggest benefit. I also think that's why Minimax and other players like GLM are so performant and just like have that extra bit of usefulness that goes beyond just what you see in the benchmarks. Is they've really embraced like long form RL, and so yeah, I mean, to be quite frank, our RL pipeline's rather immature, might be the wrong word. Like there's definitely a lot more work we could do and a lot more work we need to do, but
Have you started the tool use side of RL? Or are you
that
mostly beyond like if you're training on code, just verifying the code answer, I don't count yet as tool use. I would say
yeah,
like search and code integrated reasoning is what I think is going to be like minimum table stakes, but to do it well is really hard. Like we have to
yeah,
like you really like that's what I want to do. I want all of our models to have that this year. Search is probably you have to have like a partner to do search or just like illegally scrape Google if you're gonna serve this model onto a customer and it's gonna
yeah,
what go to Google like what
yeah, yeah. No, I mean, I beyond like really kind of like long form, like deep research, or even like GPT OSS style, or GPT-5 style, where it's doing 100 tool calls before it gives you a response. Not there yet, but that is kind of, once we get past the final kind of RL of Trinity Large, and we kind of look at where we go next, like that is the next major hurdle, for sure, and it's intimidating.
how big is your team like how many people are spending the majority of their time on the model? And then I think we can start to wrap up technical talk and zoom out a bit to ecosystem and company strategy.
uh, there's 13 at RC that are
Yeah.
just like every single day is working on it. Yeah.
And I guess that's a good number because these people are talking about data, but there's also like the whole data thing that's coming somewhere else. But also somebody
Mm,
else that wanted to pre-train a model, like they could just download the best fully open data set. And I don't think it's going to be quite as good, particularly in the fact that like if you look at Olmo's models, we don't have a lot of tokens, so we need to like acquire more
mm,
tokens in the open still. But to like get a number of 13, where some are spending a bit of time on data, but there's the whole data abstraction, is actually kind of nice for somebody that's like to do a serious modeling effort. You need to have this many people, I think.
it
That's
was,
is
yeah,
reasonable to me.
it was a good number. I mean, I would say that um it it was helpful to be able to, this was like, how do we alleviate as many concerns as possible, or how do we check off as many boxes, right? And it's like, if we're trying to do this in the shortest possible amount of time, like we need to focus on what we're good at, which is we pretty good at post training. And how do we get to the point where we're able to do that? Well, we have to have a pretty strong base model. How do we get a strong base model? We have to, figure out how to do it perform, efficiently across many, many GPUs. And then data's, extremely important. So getting a partner that could, help us with that, and we could offload some of that. There ended up being, obviously, as alluded to earlier, like a lot of uh working with Datology and others to make sure that the data accomplished what we needed it to. I think that is going to be an interesting, as we now that we have large and we're looking at, kind of going further. It's like, okay, the pre-training data really has to be in service of what you want to do in the post-training
How
world,
did you
right?
identify
Like
this? Like,
yeah,
did you identify this through Mini and Nano, or like how'd you come to think that this was so important,
data in general, or just
or like this
of
informing post
optimizing it for
training?
the post-training.
Yeah,
I really observing other players. I think. I mean, it's the true base model kind of stopped really being a thing around Quen 2, but definitely around Quen 2.5, where you started to see how much post training data was making its way into the base models themselves. Um, and then you start to see the models that have done that, how malleable they are with RL, Quen 2.5, Quen 3 being a good example. And you start to see, like, oh, yeah, like they are doing as much in the last probably 30% of training to make it so that when they go to do RL or post training, they're going to have a really good time. They're just they're way easier, way more malleable, way more performant than what you had in Llama 2 or Mistral 7B. So um, I knew that intuitively kind of going into this, but it wasn't until after Mini and Nano, yeah, where we kind of, well, definitely 4.5B, where we were like, yeah, we definitely need to juice our mid training quite a bit.
yeah, I agree. Okay, this was fun. We'll probably revisit themes for this. I think that I can
Yeah.
definitely go over time and keep chatting because I'm enjoying this. For context, Mark and I had coffee at some point when I was at some conference in SF, and I was like, "Damn straight, this is a fun bet that you're making." So I'm trying to recapture as much of this as you can. For context, it's like in July, which is similar to when you decided to start this model, which is when like Quencoder came out, Kimby came out,
Mhm.
GLM 4.5 came out, and I was just like looking at Llama had kind of been like become a meme of going away, and that's when I launched the Atom project, where I was like, come on, we need to have some people doing this, and I think that it's like hard in the U.S. because I think there's so much money to be made on AI. Like the big tech companies are like, we see it and we're gonna take it, so I don't need to bother with like caring about open models because we don't need it. But
Mm.
from like an ecosystem perspective and a long-term tech perspective, I don't think that works very well for the country. So it's kind of this weird middleman of like, how do you convince people to actually build open models? I have calls with people in government asking me like, what would I actually do? So it's like very hard to think about this. And then it's just like to hear that you guys are just making this bet on this is very fun to me. But it's also like based on actual learning from trying to do this. So you've been
Yeah.
trying to train open models. I think Mark and I have both been at Hugging Face in our past, and you were trying to sell people on using open models, and there is a market for this, but it wasn't enough to not have the base models. So I think like talking about your experience in selling on-prem open models and why you needed to train your own end to end and why you needed to train bigger is great because I hope there are more stories like this and it kind of fills a void and inspires people to work in it. So however you want to take this prompt.
Yeah, I could jump in. When I started RC in 2023, right? It was all we did was post training, and we worked with a lot of large organizations and did model customization, for their use case on their data. Um, and we were using llama-based models, Mistral-based models, and then some Quen. I don't even know if we actually did much Quen, right, Lucas, at that time, but
No, we did. Yeah, we
yeah,
later on, but and then
later on, right?
we
Uh,
did, and then we ended up not because after a lot of Chinese models started to come out, then the companies didn't want to use Chinese models, so then we kind of went. Yeah, it was kind of just tricky.
yeah, and I
People
mean
don't
that's kind
realize
of
that that's real. People don't
that's
realize
Yeah,
that that actually happened.
yeah, no,
yeah,
that's a real thing. That's why we started going down to pre-training was because, well, Meta did their thing and kind of got out of it, right? So there was the main US player got out of it, and we were working with a lot of US based enterprises that were not comfortable using Chinese based architectures. And if you wanted to use the best open models of the day, it started to really trend towards the Chinese labs. And to the point where we are now, where it's like 90+% of the top open models are coming out of China.
Like
um,
cursors building on it and stuff. Like
yeah,
yeah,
people are building on these things.
yeah.
yeah. So we said, okay, let's instead of we were so reliant on the Metas of the world, the Mistrals of the world, and Mistral largely stopped open sourcing, fully. So we said, you know what, we'll just go down the stack, and we feel we're capable enough to train our own models from scratch, and then we control the stack. We can we control the core of as opposed to relying on others to release great models. And then during this time, it just happened to be that um, there wasn't a tremendous amount of U.S. companies doing it. So from our perspective, it was kind of a win-win in that we were able to own more of the stack by going down to pre-training and creating our own models, as well as we were entering into a space that there wasn't a tremendous amount of competition, to be honest. And I Lucas and I had said this yesterday. I think as a startup, every startup doesn't want to directly compete with, X or OpenAI or Anthropic or Google because they have more money than God and they can do whatever they want. But when you're doing open weights, you don't. It's a different kind of competition. They don't sit in there, right? You're kind of going into your own path where there isn't a tremendous amount of players, and you can kind of find your way and build your niche and kind of go from there and become something big. So it kind of happened to all coincide for us back in July, and we went all in.
Yeah, like the all in thing is real because this is expensive. I think that I could dig up in my research the cost of daily um, 2048 B300s. I think I've seen this type of cost at AI too, where we have long rentals and we're like, I know exactly how much this costs. And it's like, it's not cheap. Are you, a way to transition this is like, do you see the demand? Like you were selling open models. Like, does this kind of be continuous where people are like, you helped us deploy this model, but it's not good enough? Like, is that something that's happening? And you're like, well, we have this and we can help you do it coming in this time. Or is it like you need to build it? It's like, is it a we will build it and they will come type of
Yeah.
situation? Like, how much
Yeah.
continuity is there in this?
Yeah, I think it's
I
largely, from my perspective, I think it's largely if you build it, they will come because we stopped, focusing on that whole revenue generation side of the house when we started to go all in on being this, frontier lab in the open source side. So um, there's a couple pieces to that I think we should all be very proud of inside of RC is that we not only went all in by committing a significant amount of capital, like we committed, 65-70% of our capital to these models, which is a large amount for a startup. I mean, we didn't, so that's not like a dip your toe in. That's like we're all the
Yeah.
way in. Um, but we did that at the same time as abandoning essentially the whole revenue angle to go all in on it because we couldn't focus on both. So we
yeah.
said, we know how to make revenue on open models. We've been doing it for 2 years. Now let's take a step back because it wasn't in a repeatable or sustainable way that the way we had that business set up. Let's take a step back. Let's build these models from scratch. Let's come up with the Trinity family. Then let's go back to generating the revenue side of the house and the monetization piece, which I think we are in a good position to capitalize on even more now. But we took we kind of walked away from it to do what we're doing here.
Yeah,
Yeah, I
I
mean,
love this.
when there's only like 13, researchers who would, well, we're doing obviously our own products and own models, but when you're working with customers, like inevitably those are the same people that need to help train those models for customers. And we got to a point when we were really beginning to like do mini and nano. We were getting down to like the start date of the cluster where um having myself or Mark or even Varun and others like pulled into customer or uh, conversations or contracts, like it was not, we would not be where we are if we had continued working with 10 customers at once. So we
How,
scaled that down pretty drastically. I do think that when Mark and I put a lot of thought into, okay, well, we're going to spend all this money to train these models, like how do we not, I think one of the things that makes the idea of going all in on training open weight models hard is that you've seen other people try it. And
like
like
who? Like, do you think Meta or do you think Meta or Mistral went all in?
I think, well,
Meta
I think
obviously
they
did. Like,
they both, yeah. I think that when I say all in, I mean more like Mistral was is one of the core ones I'm thinking of,
Yeah.
where they were a venture backed company that like had a fiduciary responsibility to bring in money, but were also trying to release open weight models for the West and for their communities and for the world. And they tried doing closed versions and then monetizing off of that. They also kind of have more recently, luckily for all of us, gotten back to their kind of Apache 2.0 roots
Oh my god. Have you seen the
and
download
but
numbers on Mistral 3? Large?
I haven't. Know what is it.
Oh, it's no bueno, sir.
Hey,
Carrying
but
on.
I mean,
Sorry.
yeah,
The large instruct model has 444 downloads in the last month. I honestly don't know what's going on. Maybe there's some like quantized version out there. I was confused,
maybe. Well, I
but
mean, yeah, who knows? But I think that
it's hard to get
we,
adoption. The competition is insane.
well, that's yeah. I mean, that could be a whole conversation. Also, is like, how do you
I was
actually
going to
get
ask
people to
you, like,
use it?
how do you get people to
Yeah,
resell into this? You said you were good
I,
at it.
yeah. I think that the
Continue your point. We can come back to it.
no, but I think they all kind of tie into it. Is we knew that the market was there for custom models. It was 2 years ago, frankly, and it's even more so now because RL has drastically increased the areas that you can hill climb and become really powerful on with a tiny model. Um, and but also people are beginning to see how powerful you know uh, te- or training in a product is. Like you see Claude Code, you see Codex, you see. I think deep research was kind of one of the first ones that really kind of opened my eyes to what was possible when you kind of are kind of training in the same environment that you're serving your users. So we knew that people wanted it. We'd had good success with customers in the past using other people's open models. So um, it was less of a question of like, could we monetize it or will we? And it was just a matter of could we get a model, that we would feel that given a wide suite of basically being able to pick any model in the world, what our researchers and what our teams reach towards our own. And luckily, I think we're there. Um, on the topic of like how do you get people to use it, how do you get adoption? You know, I've never wanted Trinity or our biggest advertising thing to be like U.S.
Yeah, I
like
know.
if
I
your
know, man. It
entire
hurts me. I
yeah
spent
if you're
months reckoning with this.
yeah it's if your entire value prop is that you're an American company, great, but ultimately people are going to use the best. And so I think that we're going to be able to serve and the people like that need a US based model because their compliance or legal teams won't let them use something out of China. It's going to be a fantastic option. But I think, kind of the next phase of what we're doing as a company is all right, now we've proved to ourselves and maybe the wider industry that like we deserve to be in the conversation and we can train models at these scale. Then it's like, okay, how do we train the best one? Because really, I mean, people's loyalties are very fickle, and yeah, you go to what's the best.
I guess it's like, how much do you think you've learned about being able to tune a model narrowly by going and building the whole stack? Something we talk about is like ability to
Yeah,
specialize models, and I kind of am of the opinion that you just make a better general model right now because the pace of progress is so high.
yeah,
And but the question is like, can we tune a Olmo that's very good at science or something? And I
yeah.
would guess that training the entire model, you're going to be able to actually do a better job at what you're doing. But I don't know how to articulate why or what that looks like.
I mean, the simplest answer to that being yes is just that, or the simplest reason why that's the answer to the question is yes is because we know what went into the model. Like we know what it actually saw at the later stages of training during the decay. And so that helps influence a what kind of data and what topics and what format are we giving these models in post training, but it also allows you to know like, okay, where do I absolutely want to crank, how much of this, say, 230 billion data set do we want it to be math or coding? And a lot of that's influenced by what you're able to put in
How much of your
during
post
the
training do you
training.
expect to redo? Like, how much can you say about when you're serving something on prem? Um, you're not going to redo the pre-training. You might, for a very big customer, redo mid-training or do continued
Yeah,
pre-training, at which in that case you do need the pre-training data to keep it being stable. Which is a
yeah,
use case, or like I would love to see a paper that's like, because of Olmo being open, we continued to pre-train on biology and we mixed half of their exact mid-training data set in with our data set and it worked yada yada. Like you could obviously
yeah.
do that. But how much do you think is going to be like the standard? You fine tune the last instruct model, or are you going to have to retouch the post training for a customer? Because that, like, I really feel like it's
Um,
just at the end.
it,
But
I
it would
think
be
I
fun if you
think
had to change it.
for the most part, um, I think a lot of tasks will be fine just starting from our like the released, official post-trained version. Um, Now that's for maybe simpler tasks is the wrong way to frame it, but if it's like, oh hey, we're doing a deep search agent, we wanted to do 30 calls and before that would be a good use for just starting with the finished model that we released that's already post-trained. Now, if we're going into something along the lines of a very low resource programming language or um, something that it didn't see a lot of in pre-training, um, or it's kind of like we're wanting to train this thing to be really good at humanities last exam with tools. Once we get into the world where we're having to, especially, actually, I have a much better answer to this question as I was thinking through it, but most of that holds the same. I think that the world where we're going to be doing a lot of extra instruct and SFT and post training is going to be when we're trying to distill capabilities from large like into mini or nano. So say
Yeah.
like, oh, this large is really great at invoice processing, but it's also 400B and the company doesn't want to be hosting that on prem. You know, let's go
Do you have
out,
costs off
generate
the
a new
top of your
one.
head for like what the hosting costs are per each of the model? Like, do people are people all going to host these models in the same way, or is there actually a
Uh,
wide variance? And if you have like the same three models, do
yeah.
almost all of your customers end up hosting the same way, or do you end up doing a lot of like how do you configure the model to fit in the right hosting for them? Like, is
It
that part of the
depends.
business model?
It kind of when we tried to move a little bit further away from that because you get into the risk of being like a consultancy and it's that becomes tricky where there's not a very clear separation of concern. But it would change depending on were they using AWS? Did they have a commit with Azure? If not, okay, then we can go to someone like Prime Intellect or Parasail and get maybe a cheaper rack of eight. It just really depended. There's quite a bit um, of people that were also serving them just using like Llama CPP. So
Is
like
the
on CPUs.
400B designed to fit onto one rack of 80 big gigabytes in FP8? Is that how you designed it? Because
Yeah, yeah,
Llama 4, whatever Llama 405B was the same. It was like
yeah.
one rack in FP8. It works pretty well.
It'll do. You'll be able to get really good throughput, a little bit lower concurrency on a rack of eight H100s at FP8, and then for like what we're serving them on a series of H200s, but we're not doing like multi-node inference. But that's just to add more replicas and
Yeah,
that kind of stuff.
hopefully eventually. I think that, do you have anything else to say about selling open models? I think that generally, like, how do you think about the market for AI? Because I see the market as being so big, but with specifically with open models, it's so hard to measure. I think I've started talking to some of the Chinese labs at all as well, and I like to ask them like, this is very U.S. centric and like Fortune 500 or whatever, and it's just like, who the heck uses these models? I guess another question is like, what license or do you know the licenses you're going to use for the biggest models? And I think they're like you're playing with fire because people can use it for free, obviously, but
Yeah.
potentially you'll get to hear like oh shit, somebody actually used our model for this. And I think any successful business, you're gonna want you know that this model is not going to be very relevant in a year with the pace of progress. So like,
Yeah.
how do you think about your license decisions?
We, with the 4.5B, we tried to do like a one of those revenue gated licensing. So it's like, oh, it's completely free for you to use for commercial and whatnot. But if you or your company made over, I think it was like 1.7 million last year, then you need to come to us and get a license. And what we ultimately found was like, it didn't, maybe for some people who are just only trying to train the model, release it on Hugging Face, and then just call it a day. Maybe that is a huge requirement, but when so much of our company is built around, you know, training custom versions of the models, and not even just ours, but in general, even before we did pre-training. Like at the end of the day, as long as we were using it and we knew that we were in full control of what, if we really succeed, it's because we trained the models, we did them well, and we executed on it well. If we fail, it's because we uh, didn't execute instead of, oh, some company just stopped releasing good open models. So we eventually switched to just Apache 2.0, and Trinity Large is also going to be Apache 2.0.
I think
I
this is
think it'd
the
be,
right approach. I have a
yeah, I think it,
manifesto without naming other companies. It's easy, like raising a lot of money, or being meta and releasing open models and do it. You could release it with non-commercial, and you could get all these like, you could talk to I don't know, fucking Adobe, whoever. Oh, Adobe's too big. They'll have good AI. Some, I don't know, a Bank of America. You could run Llama and Bank of America and make good money on this. But I
yeah,
just feel like the cultural home of open source AI, and I don't think it's impossible to know who wins it. And I don't think that you're in the prime position, and I don't think that it's easy to win, but you're doing a thing that aligns with it, is the person that just like commits to building the models and learning how the ecosystem works and to rebuild the models based on the feedback that you get from people and to just kind of commit to an evolving process. And if the whole thing works out, there will be a lot of value, and the person who understands it best should be able to learn how to extract said value. And I think that I'm personally like sometimes frustrated with Hugging Face because I feel like they have sat on that a sort of position like this and they haven't
mm-hmm,
figured it out. Not that it is easy to figure it out, but I think that has to be the ideal of open source AI of like if it's really gonna work. That's what I hope it looks like. And it's like I don't know, maybe you guys could do some of that. Like I have a question of like, do you figure out how to make models that are more fine tunable after all
mm-hmm,
this post trading because you need to
mm-hmm.
sell it to a you need you
Yeah,
know the customer's not going to want it off the shelf. And I don't
yeah.
know how to train to post training to make sure that you don't cook it. Maybe you just learn that you need to warm up the model in the right way, and you just learn the technique of training downstream. But when you talk to people doing research, the different base models have such different characteristics. I think one of them is character training. I did this paper, and the guy was like, Quen and Olmo love their character, and I'm like, I have no idea why. And but
Yeah.
he's like, Llama and Gemma, you can change them so much. And I'm like, dog, like, please figure out why this is the case. If for one thing, it's really cool, but also like in your case, that would unlock a lot of value to be like, we know exactly what the model is going to do, and we know exactly how to change it.
Yeah,
I don't know.
it's that's no, you're right on the money. I think that even going into the post training at large, we one of our researchers came out with like a pretty cool um, experiment and ablation run that they did on drastically reducing catastrophic forgetting. And I mean, this was like 3 days before we were going to start doing SFT. And then we ultimately just, I ended up pausing on it because it was just throwing something in that wasn't tested. But
A
yeah,
good
I mean,
research lead. You did the right
yeah,
thing.
I think one of the most important things long term, as we look at kind of what our research priorities are for this year is there's obviously just how to scale RL and make the end result of the model as good in as many situations as possible. Um, but I think the other half of that is, how do we make the speed and efficiency and performance of customizing them as fast as possible and as easy as possible.
Yeah. Do you learn in making open models from your experiences kind of running these open software things in MergeKit and DistillKit? I know there was a whole license journey on one of those as well.
Yeah,
Or do you feel
DistillKit,
like they're
yeah.
kind of
Or MergeKit.
isolated?
Um, yeah, I mean, I think so. I think that um, you kind of have to play the tape out. With MergeKit, it was by far our most popular piece of software we'd ever released, but it was so popular because it took something that isn't fundamentally very complicated, but it's time consuming, and standardization is great for things like that, and we made it you know, streamlined and easy to do and fast, and you could experiment and ablate really quickly for, and so I think that when we switch that to like a similar uh revenue based licensing, like it didn't end up having the value prop that was important, because are you going to pay RC, thousands of dollars, or are you just going to have one of your researchers
You're gonna have Claude
recreate it
Code
in a week,
rewrite it
right? Yeah, so it's
in a
it's
day.
kind of it's remembering, like, okay, what problem is this solving, and is this even a problem? Like, is the solution to this monetizable? And so MergeKit, we brought it back to the original license, but I think with even viewing the models in the same way, it's like it's open source is an unbelievable marketing tactic. Like, there's no one would care about RC if we weren't open sourcing stuff, because as soon as you do something closed source, if you're not the best or the cheapest for your price point, I mean your performance point, no one's going to use it because
Another question on this. Do
yeah,
you think that open models are kind of at a disadvantage when progress is so high because it's potentially easier to swap APIs than open model configurations, especially if like model weights are changing sizes or something like
yeah.
this, where it's like, oh, I could just upgrade to the new Opus and I do this? Like, does that like it decentivize people from using it? Or do you think most of the people are like, I can only use open models, therefore I'm going to use open models?
I think for the people who are using like either self-hosted or you know uh bespoke engines to run it, where they have complete, in a VPC, or they have complete control over like data in and out, egress, ingress. I don't think that's really going to be so much of a problem, because they're obviously doing it for a reason. Like, they're either for privacy or security or HIPAA or SOC 2, for whatever reason they're doing it. I don't think that that'll be so much of a blocker, but I definitely do think that um, by far, even with some of the larger open, like inference players like Together and Fireworks that host a lot of open models, like being on feature parity with a lot of these larger labs' APIs is going to be extremely important. Of being able to serve, um, with features that they're used to, like prompt caching, that kind of stuff.
Yeah, are you, like I think I saw that you guys are setting up an API as well. Is that kind of what the vision there is being able to offer parity at least, or like make it easy for people to consider it?
I think so. We very, yeah, we are doing our own API. We are hosting it. Um, we haven't we push a lot of that through Open Router, just because it's such a great place to get like discovered.
Yeah.
Um, as if we see like tremendous growth there, that would obviously be where we'll invest very heavily. Um, Whereas the right move might be to let other people host it, and we invest super hard on the infra for like taking advantage of the models, and customizing them. And there's a few avenues we have ahead of us, and we have, projects going kind of toward to poke at each one, and we're just kind of getting as much data as we can before we. I mean, we're gonna have to go all in on another direction soon. Not like pivoting away from pre-training, but now that we've done that, now what's the next big bet we're going to make, and how do we go fully into that? So we're trying to figure out what that is.
Yeah, my two last kind of like real questions are like one is I guess we can start with like where do you see the open model ecosystem? Do you think where would you see it changing substantially in the next 6 or 12 months? I like or do you? Or do you just kind of think we're marching along for a while?
No, I think we'll be. I don't think it's an unrealistic prediction to make that by the end of 2026, like the best model in the world is some degree of open. I think that's very, very possible, especially with like what I've seen GLM and Minimax do recently. They have started to find that secret sauce that takes you out of just being good on benchmarks and like genuinely useful in people's day-to-day workflows. And um, I wouldn't like if I came back and someone came from the future and told me that the best model in the world was an open weight model, I wouldn't be surprised. I actually think we're on a super good trajectory, and fostering and promoting that kind of work and adoption here in the United States is going to be extremely important.
And where do you see the company going? Because like I have my guess. Like you can kind of
What's your
hopefully
guess? I want to hear
you
your
can
guess.
hopefully do a mix and kind of oscillate into trading when you get like you need to start having the feedback of the real world. I think that's
Yeah.
like that's like it's well obviously you need to make money to survive as a company, but then you need to start using that as the feedback to guide trading, and then it's like you need to figure out how to balance and do some of them at each time, and you can plan your cluster at different times, and then you kind of hopefully they become a loop across each other, and they kind of make it so obvious of why you each need them because it seems somewhat natural.
Yeah, I mean, exactly. You kind of hit it right on the head. Getting feedback and then kind of steering the ship from there is probably exactly what we'll do. But we have a good idea already. I mean, first and foremost, we talked about it earlier. We've spent a tremendous amount of money, so we need to go raise some money after we after we get we need people to back the mission and the vision of U.S. open source and so because Lucas had mentioned about like merge kit and how we flopped the license and I mean, we're a smaller size startup. We got to think of kind of unique ways to try and generate revenue because we don't have the money of the large labs. So,
Well, I think it's a benefit to the employee. I think a lot of these labs have overraised. I
yeah,
mean,
I was
like
gonna.
OpenAI,
I
Anthropic, and all of them are fine. Like with the OpenAI, Anthropic cursor scale, like let it rip. They should really rip the raising. But
Mhm.
all the other companies that are stuck in the like the 1 to 2 billion range without like obvious traction, like the risk goes to the. I mean, you could a lot of them do secondaries, so a lot of the founders get out. But it's like the risk is the employees get nothing. Like
Yeah,
there
yeah,
is a lot of money, but that's also why I like the approach because it's like, oh, you're doing the actual startup thing.
yeah, yeah, yeah. I mean, I think what I was gonna add to what Mark was just like what whatever we do from a scaling and speeding things up and growing. My goal is to keep our research and engineering teams pretty small. I think that one of the reasons we've been able to move as quickly as we have is it's been like a small group of like highly intelligent, smart, and opinionated people sitting in a room debating in good faith on decisions. And I think that's under the constraints of, hey, we don't have $500 million to go and to rip on X, Y, and Z. So, and I think that's kind of where creativity comes from, and I think that fostering a culture like that over time is how you can kind of make it so that excellence is less of like a um, an accident, and it's actually like a byproduct of the way that you work. So we're gonna stay small, we're gonna stay lean, but um, I do think that like the major kind of challenge for us over the next probably 6 months, beyond any other models we might have, kind of we're thinking about is getting up to like post training parity with the likes of DeepSeek and GLM, Quen, and others.
Yeah, I hear lots of war stories about this where it's usually it's you end up having people that are going after different important abilities, but like doing each of the abilities alone is pretty easy to hill climb. But then you just end up with such a mess. It's like you're
Yeah,
building a custom puzzle and you're building all these custom pieces and they're magnificent, and then you have to like pick up these pieces and assemble this unknown thing at the end. And it's
yeah,
like
that didn't
like
have a
even
single
AI2
designer, right? Yeah,
is AI2 is barely scratching the surface of this. Like you talk to the people at the Frontier Labs, and it's like, holy cow! Like post training is really the Wild West, but a lot of it works. I think like we find like even like model merging gives a ton of performance across the whole
yeah,
training pipeline. It's like
yeah,
you merge after each pre-training stage, you merge in post training. It's like But merging
Varun can
post
tell
training
you,
becomes a lot more complicated because you can have
yeah.
all these domains and things.
Well, in merging, it actually it used to be very YOLO, the way we used to do it, and Charles, who created MergeKit, I call him like chief alchemist, and like you'd kind of just send him 10 promising checkpoints, and he'd come back a day later with like some insane, model that was really good at all of them, and you can't do that as much in post training anymore because of just the formatting and the way that RL is done. Like you do have to be a little bit more surgical about it, but yeah, Varun can tell you, like anytime we start to see anything worrisome at all in training, or even something going really good, Lucas, what do we do? I'm like, merge it. Just merge it. Let's see. And more often than not, it fixes it. So
Do you merge during RL? Like you could just like merge the last few checkpoints and resume or something?
we've dabbled in that, not for what we've done. Again, a lot of the mini, nano, and large story for Trinity is like getting to a level of what was my level of complexity I was comfortable with us undertaking, and then not introducing anything more. So not yet, but we regularly merged. We didn't do it for large, but we used to merge a lot during just like your standard when we do like RLHF. We used to do a bunch of merging. We do it like every 5 checkpoints. We would
Online
merge with the
RLHF
previous
or
checkpoint.
DPO?
There's Dig DPO.
Yeah, it's so much easier to get started. One of my goals is to have somebody figure out how to do actual online RLHF, pure LM feedback, obviously for scaling, but it's just like
Yeah.
it's unsavory to. It's just like doesn't look
Yeah, I
right to
mean,
do
if
DPO all the
if
way.
GRPO and kind of in the present day RL regime, like if that hadn't materialized when it did, I think that would have been a big topic in 2025. But I do think that GRPO and just the overall DeepSeek and O1 style reasoning and thinking and RL kind of any person who was thinking of doing that for like performance reasons realized that there was something that had 50,000 papers released every day on how to do it.
Yeah.
That was kind of probably right where you'd get the same amount of performance.
Do you force dog feeding? Do you make yourself? Do you guys use your own models to understand them? Like, do you like make
Uh,
that a thing?
Mini was the first one we could actually start doing that with. At least for a more general day-to-day tasks. So a lot of our like internal Slack, we have stuff that like monitors Twitter and LinkedIn for feedback on Trinity and that kind of stuff. That all runs on Trinity Mini now. And then we put a good amount of work into Large being um, good in a bunch of your like open codes and clients and kilo codes. So
What does
um,
that? What does that work look like?
working with those guys to get data. And then
That I mean,
yeah,
good for me
I
to
mean,
know. I should do
yeah,
that, I guess.
yeah, yeah. Working with, or I mean, the way it started was us like using open models and then like passing those through as the base URL, and then like getting the logs from that, and then realizing that like that translated pretty well, um, and then over time,
Can you
obviously
expand on
turning
this?
those.
So I was going to ask you if
So
you're like using these open models regularly, because I'm just like Claude Code psychosis man. I'm like can't take that
yeah,
away from me.
I've used 4.7 a lot. I think 4.7 from GLM was one of the first ones that could replace a lot of my day to day. I'll still reach for Claude Code or even 5.2 Pro if it's like something that's like really I if I do not know how to measure what success looks like for something, I'll usually use that. But yeah, I mean even using DeepSeek before kind of their May update was hit or miss. But um, yeah, the reason I decided to like start talking to these people and working on like how can we get data and start making our models good in these systems was I would use them. I had a um, something that would grab the logs like it was a proxy, so it would like grab the logs and then format them in the messages format. And then I saw that and went, yeah, that's you can make a pretty good filter for just like standard stuff that you don't want, and kind of hit
Yeah,
it
that
at
makes sense.
scale.
So you
Yeah.
like open code will let you look at the data, and then you're probably going to get a sense for like I don't even actually know how the on the back end the code agents in open code format data, which I think is actually something I should just go look at because then you can
They're all
design around
different.
it.
Yeah. Yeah, but you just have to, you just basically it all starts from like, what do you want your format to be? And then how can you take what those look like to, to how do you force it into that? The hard thing though is with newer models like Minimax and 4.7, the way they do interleaved thinking is like, I'm a big believer in post training. Like if you're going to do interleaved thinking, like every sample in your data set should be that. It should follow that same format, that same behavior. So that gets tricky if you're trying to like take a bunch of or well, like uh, DeepSeek data and Quinn data, and then we're also trying to mix in Minimax, and at that point, it gets really difficult because they all handle thinking slightly differently.
Yeah, I can buy this. Um, okay, this was fun. Any last predictions or things you want people to know about the model? I will say that when you debuted the Trinity models, you had a great blog post that was very to the point that covered a lot of
Mm.
this. So I'll definitely link to what is it, the Trinity Manifesto. I enjoyed
Yeah,
reading it. So I'll link to that in the show notes. And oh, hopefully you have a new one for me to read when you
Yeah,
we'll
launch
do,
it.
yeah,
I
and we'll
don't
have a
know.
tech report. We'll have a
yeah.
tech report for you too. So we never did a tech report for 4.5B mini or nano because we were so focused on just getting to large. But we also thought it'd be very interesting to write it under the how do you go from 4.5B to a 400B MOE in 6 months, and like what did we learn when you're viewing it as a whole? So
That's about the time frame that Ant Ling took to as well. Ant
yeah,
Ling, the Ant group, we talked to them. And they're like, it took us about 6 months to do Ring 1T and their 1T models, which like it sounds like a lot more, but I think that's about the same. It depends on compute and configs and stuff to go from
yeah,
like basic modeling to big MOE, which is pretty interesting to see a lot of people speed run this sort of thing.
yeah. It's a really uh, it is a logistical nightmare, but like I think everyone on the team has had a tremendous amount of fun over the last 6 months. So now the fun begins.
Yeah, congrats on the milestone. Congrats on the model existing. That has got to be an almighty relief, and I'll look forward to see what you all are up to soon. I'll stop by some point next time I'm in the
Yeah,
Bay.
yeah. Come by.
Yeah, come by
Thanks for
anytime.
having us.
Yeah, thanks, guys.